How you doing, Scott?
Good.
Good,
Everything's very
good.
well. Thank you.
All right, all right. Well, we'll get this started off just as, as usual. I just want to see if anyone has any questions or a particular topic that they wanted to talk about. Sophia or
I
Christy,
just,
were there any questions you guys had?
I've just been watching through the videos and I was thinking about the double slit experiment. And
Yes.
it's probably not an easy question to answer. I was just wondering
I,
more
I,
detail on how the wave pattern appeared.
um, so you were saying you have an image of like the parallel line. Is it something like
Yeah,
this one
going
here?
going up and down. Yeah,
Right.
like
Okay.
that on the screen. But
Yeah.
that one with lots of parallel lines going up and down. Mm.
Yeah.
I was
So,
wondering,
okay.
is that a like gravitational wave side on going like spiraling towards the center of the universe of the Earth? Sorry.
Right. Okay. So this is, I'm glad you asked that question. Okay. I think it would first, just for people who listen in later, let's see if we can find, an example. I like this one here. Okay. So here we have the similar thing, but with water waves.
Oh,
And you can see there's a
yeah.
slit here, and then there's another
Hmm.
parallel slit here. And the idea is that
Hmm.
when waves come towards this blue wall and they go, some of them go through here, you can see this circular pattern that's happening
Hmm.
on both
Hmm.
sides. And then when, as these waves are expanding outward, these liquid water waves or whatever they are, you can see when they cross, they create this pattern. And
Hmm.
they're not showing it here, but if there's another wall, kind of right here, you would then see this
Hmm.
pattern on that wall.
Yeah.
And so that's what we call a
Yeah.
wave interference pattern, right? And so
Hmm. Yeah.
with the double slit experiment, the idea was that they were firing one particle through
Hmm.
and let's see here, let me see if I can find a, yeah, I think this is like an actual, what,
Hmm.
idea of what they would, the interference pattern that would show up on the detector wall. Okay. I like this right here. Okay. So, so I'm going to kind of describe this first in terms of, um, standard traditional science, and then I'll try to
Hmm.
do it in terms of Walter Russell's. So
Yeah.
in traditional science, they would have a light source, and, that light would be radiating out. Here's slit one up here and slit two down here. And so then on the other side, they had the screen, and you can see how there would be an interference pattern. So they were fine with that. But what started to baffle them was they started to just send one particle at a time through. And forgive me, like this is, like I said, I'm going to do a video on this, so I haven't done like all the research on it, so I'm mainly going from memory here. So um, if I say anything wrong, it'll be corrected in the video that I do. But it's my
Hmm.
understanding that they would send one particle, and so the question was like, okay, if it's one particle, shooting through, it it should go through one of two of these holes. So it should go through and like land on the other side and just, you know, be in one place. And if they shot another particle, maybe it would go through the other slit and it would land in one place. And so the idea was that if they just kept shooting one particle at a time, traditional science would tell us that there should just be what we would see on the screen, on the detector screen, would just, there'd be one place like right over here where all the particles that came through this side would land, and then particles that came through the bottom side would land and be over here. So there should just be two distinct, um, you know, uh, like a pattern of just two distinct places where the particles were hitting. But to their astonishment, when they did in fact shoot one particle through at a time, they started to see that over time, like after they shot like, 1,000 particles or whatever through, it still built up this interference pattern. And so they were like, how in the world can this be possible? It's and it opened up a whole door of like, people talking about quantum mysteries and like, the particle, you know, how does it know which slit to go through and like what's happening, and is it because we're looking at it, if like when we observe it, it affects, the the wave, like they have a thing called what is it, the collapse of the wave, I think, or the collapse of the wave function, something like that. And because the idea in kind of like quantum mechanics is that you don't know where a particle is because we can't like measure it exactly. So the idea is that we don't know which slit the particle is going to go through. And quantum mechanics would tell us kind of like, well, it's like going through both of them at the same time. And just kind of this kind of weird stuff like that. And so it was a big mystery, as to why an interference pattern would be built up over time, when they're only shooting one particle through. It's like if you can imagine just like shooting one ball, through, one at a time. So now in Walter Russell's concept, now this is, I don't know, I might be the only one who really has ever talked about this, but it's my opinion that Walter Russell's concept explains why the interference pattern is built up. Now, so first I have to give you guys for people listening, later on, I want to give a little description of, so in Walter's concept, let me see if I have a visual for this. And so you guys see this south inertial plane photo? Okay. Okay, so this actually is a graphic from, part of it's from the Universal One, part of it is that I created for my presentation at the 2023 homecoming at the USP. So what we have here, the idea is that this one circle over here is like a planet, and this, or say it's the sun, and this other circle is a planet. So P and Q. And so with Walter Russell's concept, the concept of gravitation and radiation are the two forces in his concept, okay? And he says that they move in a spiral, and they're either going, if it's gravitation, it's moving in a spiral that is, getting smaller and smaller and heading towards the center of mass, which he called north. So you can see where I have north, and north, is at the center of the planet, and or center of the sun and center of the planet. That's north. And so anything gravitation, the force of gravity is headed towards north. Okay. Now, radiation is the opposite. It is the force that is headed away from the center, and it's spreading out, and it's headed towards south, which in this case, and it's kind of hard to see, but there's a minus sign here in the middle, and this kind of peach colored, pink colored plane is the south inertial plane, he called it. But that is the point of south, which would be like, way out in space. Okay. Like, as we have the sun, and then we have the earth, and there's a bunch of space in between, right? So in Walter's concept, the light that's coming from the sun, it will, when it leaves the sun, it's expanding. Okay, it's getting larger and larger, getting, because when it was in the middle of the sun, it was highly compressed in a small space. As it leaves the sun, it expands outwardly, and it gets so expanded that it reaches a point somewhere in between the Earth and the sun that is called the inertial plane. There's an inertial plane between all things in any kind of matter. Um, if you have two pieces of matter, then somewhere in between those two things, there is an inertial plane. Okay. Um, so, and this is unique to Walser's concept. So when the light comes out and it's expanding, in that radiative way, it's expanding. When it hits the inertial plane between the sun and the earth, it then flips and then it starts contracting as it comes toward the earth. So what's essentially happening is the light is, um, when we're on the earth, we feel the sunlight as heat. Like we could literally feel, you know, the light on our skin, like heating up our skin. If anyone's gone to the beach or whatever, and if you sit out there in the sun, you will get hot, right? And that is because the light, when it is headed towards the earth, after it's past the midpoint of the south inertial plane, it is starting to compress and get smaller and smaller in a gravitative way because gravity goes towards the middle of the earth. And or in this case, when you're sitting on the edge of the earth here on the beach, it's this cone it's gonna come to a point right at your skin. Okay, because there's an inertial plane between the sun and your body somewhere out there in the middle of space. And so at some point, the light goes from the sun and expands, hits that inertial plane, and then starts to contract until it reaches your body on the earth. Now, depending on where you are, that light is going to feel different because we all know that the sun is super hot, right? And we all know that like you feel the sun hot on your skin, when you're lying out on the beach. But if you were to go up in a rocket ship, out into space, it's not hot. It's cold out there. And that's because the light is so expanded in this area between the earth and the sun that we wouldn't feel the light as heat. It'd actually be cold. Okay. And so and one more thing. So that's the general concept that I wanted to get across before I explain the double slit experiment is that, light expands, hits a south inertial plane, and then it contracts back. And and it's actually Walter describes it as there are cubic wave fields and that the light is repeated so that the light that we feel, the warmth on our skin, we traditional science would say, hey, that's the light coming from the sun and, hitting our skin. Well, Walter would say, well, actually, the light that hits your skin is not the same light that left, the sun. He would say that the sun started an action, a radiative action, and then it was repeated in cubic wave field after cubic wave field all across space until it reached your skin. And the light that is hitting your skin, um, because of this expansion from the sun and then contraction headed towards the earth, the light that's hitting your skin has just been reproduced and is contracted to a small enough space that you can feel it as heat or hot. So it's the light is really just a recompressed kind of what would you call it? Maybe you would call it a reflection. So the wave field that is right at your skin is the one where the light has become compressed enough just uh, because of the atmosphere of the Earth and everything. The Earth is high potential, the sun is high potential, and in the middle, the space in between is low potential. But as it's traveling from that low potential to that high potential, there's a gradient of pressure and potential that compresses the light. This gravitative force compresses the light down this spiral vortex so that by the time it reaches your skin, it's compressed enough that we can then again feel it as heat. Okay, that we'll get into the cubic wave field later. That is after everyone kind of watches the beginner material, the intermediate material, and we'll get into the advanced material. But okay, so anyway, now I want to go back to the double slit experiment. So if we keep this in mind, so let's take this graphic back off here. All right. Well, anyway, back to the double slit experiment. So this is after studying Walter's concept, I went back and I looked at the double slit experiment because I always thought, I was like, wow, that's weird, and it's funny you mentioned the double slit experiment, Christy, because this is the experiment that got me to start studying Walter Russell stuff and others because I was like, it was clear to me something wasn't right. And I was like, there must be another explanation. And in just my intuition kind of told me, well, if they're shooting one particle through, it must be, and it's showing up on as a wave. There must be something flowing through here. And so in Walter's concept, this light source, whatever it is, when they turn it on to send one particle through, it would be a radiative effect. I haven't done the research on what kind of photon gun or light gun. I don't know what their light source is yet. I have to look into that. But assuming it's something that the light would be coming out, that would be a radiative effect. So this is kind of it gives you the idea of that. You could see how this is like radiating outwardly. With Russell, from the point of the light source to the screen, he would say that somewhere in between that space, there is the south inertial plane, our good old, this guy right here. And so that the light would radiate outwardly from the light source over here, would radiate out, hit the plane, and then would start contracting. This is when I say the light is radiating out and then is starting to contract, this is because of his forces of radiation and then gravitation. Okay. And those forces are invisible. Like we can't see gravitation and we can't see radiation either in terms of the force. But as he described it, it's like a stream, and those forces are like a stream flowing. And if we think of any piece of matter, any particle or piece of matter, that piece of matter would be flowing in that stream, in that gravitative stream or that radiative stream. And it would be following along that, it'd be controlled by that stream of forces. And so I thought about it and said, okay, well, if the double slit experiment, even if they send one particle out, it's going to first follow the radiative path. Okay. And it's going to reach, it's going to go through one of these slits, but it's going to follow the gravitative path, which would be compressing it back. And it's going to, hit the screen. Now, if regardless of which hole the particle goes through, oh wait, let's see, how do I describe this? Okay, if we think of the radiation being on this side coming out of the gun, and then over here, some we don't know exactly where, but somewhere in between, the gun and the screen, there's an inertial plane, and then there's going to be a gravitative stream, if you will, of force. So this stream of radiation and gravitation is there. It's invisible, but it's there. And and it's almost like you see these lines that they have, these kind of curved lines. These are similar to the 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 graphic I showed you before with the water. Like these are kind of like water waves. And some would go through here and some would go through here. And then, those curved lines, you would create the interference pattern. So I thought, well, if Walter Russell is right, then the radiation and gravitation should be there. It's going to be like as soon as that light is turned on, the radiation and gravitation forces are there. And they're there through this whole area, through this whole area. So so if we imagine that stream, like I said, if you imagine it as like a stream, then when they turn on their light source, even if it's just for a split second and a little particle comes out, well, the particle, in my opinion, and with if I'm interpreting Russell's concept right, the particle is going to follow the stream of radiation and then gravitation and land over here somewhere. And then the next one they shoot is going to do the same thing. It's going to follow the stream. Now we know you can imagine if you're standing by a river or a stream or something and you throw a little stick in there, well, you're going to see it go down the river. And then if you throw another little stick in there, it's going to go down the river, but it might take a slightly different path, right? But it's still going to follow the river in general. And so that's how my interpretation is that when they send one particle through, it's going to follow the stream and land over here. It's going to follow, and the next particle is going to follow the stream and land over here. And as they continue to do that, it's going to build up the interference pattern because the gravitation and radiation, I'm sorry, the radiation on this side and then the gravitation on this side, that stream of forces is always there as soon as they turn on that gun. And therefore the particle is going to follow the stream and land over here. But because the stream, just like water would create an interference pattern, it's my opinion that the stream of radiation and then gravitation would create this pattern of interference. Like if we could see it, we would see something similar to where there would be an interference pattern. But we can't see it. But what we can see is obviously the matter that they shoot out, the little particle. And the particle has no choice but to follow that stream of radiation and gravitation and land over here. And in my opinion, because the radiation and gravitation looks kind of like there's one, let's see, radiation would come start here at the light source. When it hits here, somewhere in between, this pathway of, you see this arrow going through one of the slits and then over to the screen. Somewhere in there, will be radiation and then gravitation. And the particle will follow, any particle that goes through here is going to follow that path. And any particle that goes through this side is going to follow, the path over here. And this path of gravitation is different than this path of gravitation. And the two gravitative streams will create this interference pattern. So when the particle comes through, it is going to follow the stream and it is going to land only where, like, it's only going to land where in these little bright areas. And that's just because the stream of gravitation is, that's the pattern of the stream of gravitation. So the particle has to follow that stream. And so that's why as they shoot one particle after the other, they start to see it land and build up this exact pattern. And it's my opinion that the particles build up that exact pattern because they're just following Russell's streams of forces of radiation and gravitation. So, um,
Do you think
yeah,
in this experiment are they affected by the gravitation heading towards the center of the Earth as well, or was it some? It's not like it can be isolated, so it's
yeah.
got
Oh, yeah,
any other.
it definitely would be. Um, as Russell described, gravitation is everywhere, and it affects everything is affected by it. So yes, yeah, like the experiment would of course be affected by the the gravity of the Earth as well.
Mm-hmm.
Um, as well as the so in Russell's
That would
concept,
give it.
sorry, go ahead.
I was imagining that giving the parallel lines some depth, like they kind of. I don't know. I need to think about my question more.
Well, yeah, yeah.
Yeah.
Well, one of the things that there's a great graphic. Well, Russell, I think that's in the home study course. Anyway, Russell points out that traditional science thinks that like light waves kind of travel parallel, but he says no, it's not. It's never. They're never parallel. They're because everything is curving. So, yeah, that's not like so yes, the gravity of the Earth would be affecting it, and still the lines would not be parallel. I guess is what I'm saying is so you're right. Like the gravity of the Earth would affect it, and in his concept, none of the lines would be parallel. They would always be flowing in a curved spiral. And he describes it as um, a wave. That light travels in waves, and and the motion of that light is kind of spiraling around a gravity shaft, is what he says. Which we haven't really gotten there yet. That's more advanced, but just from kind of like a beginner slash intermediate kind of understanding of Russell's concept. This is we can almost imagine if this south inertial plane here in the middle was like the wall, like if we put two slits in this south inertial plane, we can see that like, and if this was our light source over here, we could see one particle might go through up here, another particle might go through down here, but then, on the other side, they're going to have to follow. Now, let's see. Well, this would only be accurate for the radiative half because, yes, there's nothing blocking the radiation from the light source to the wall. But on the other side, this would not be accurate because, like, on the other side, this wall is blocking, you know, the light. So it's more like this, where you would have it's almost like having a light source here and a light source here. Once you're on the other side of this metal sheet, it's like two light sources, or two, streams of gravitation. And so when you have two streams, they will create an interference pattern. And those particles just kind of go through there. It's almost like what would be another example? Oh, I know what I'll do. I'll go back to this one again. We can imagine if this is like water, and you put a little stick, that kind of would just float on in the water, it'd be going along like this. And when it went through this slit, then it would, it's kind of random. It might kind of go over here and follow, these waves, or it might kind of go this way and be getting jostled around and everything. And, you know, And same as, if a stick went through this side, same thing. It would just have to follow this weird interference pattern. And so, because it's just going to be taken by the stream. And so that's my kind of, my idea is that the particles that they were shooting through were just following the stream of gravity. And that's why the interference pattern was built up that way. So, Christy, I don't have any proof of that. It's just my like if Russell's concept is right, that's my interpretation of it, of why it would build up an interference pattern that way. And to me, it makes sense. But yeah, it's a fascinating, like I would love to be able to kind of prove that in a laboratory, like it just
Yeah.
it takes resources.